All right, so welcome everyone. This is our second 2022 OWASP Los Angeles monthly virtual meeting, and we have Robert Hansen that's going to be presenting his talk about a NaN issue. It's a very cryptic, intriguing title for me, at least. I learned a whole lot about it, and I saw a bunch of tweets about it on the internet that was also interesting. So the board of directors of OWASP Los Angeles are the people that you see on the screen. Although this is only 1 hour, it takes a lot of time from us to prepare for it. We're seeking speakers. If you know anyone that's you feel is going to be a good fit for this topic and this chapter, please refer them to us and encourage them to talk about their specialty in here. And I really am appreciative being part of this team. Cassio, which is on right now, and the rest of the team, unfortunately, they're all tied up today. They couldn't join, but a big thank you to everyone. I'm going to play this short video, so bear with us. It's an introduction to OWASP.
It's a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100+ active projects, and new project applications are submitted weekly. Projects are open source and are built by our community of volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections. And recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Navigate this thing, it would be nice.
It's a nonprofit.
Okay, so we are on social media, not almost all of them, but we try to keep current and notify our followers of upcoming events, both for our chapter and also for OWASP Global. We meet at the 4th Wednesday of every month, so that's a set schedule. For now, we're all just virtual and plan on hopefully going in person as the COVID and this virus fiasco hopefully dies down. We also are encouraging our followers and people who join us in the meetings, if you have any aspirations to be a presenter and talk about your specialty in conjunction with AppSec, we are trying to find people who can present for maybe 15 minutes before the meetings about one of the OWASP projects. So if you're interested, let us know, send us your material, and then we'll consider it for upcoming meetings. I'm not going to talk about the benefits of becoming a member, but membership is really, really affordable. It's only $50 a year US for your membership. If you're a student, it only costs $20, and it brings a wealth of benefits to it. And in addition, you are promoting a really good branch of the information security AppSec to the entire world. So your dollars goes towards a really good cause. If you know your company or any other company that you're in touch with, they're willing to sponsor any of these events, please let us know. The contact is on the screen. Right now, our meetup has over 2,400 members. Next month, we have another presentation lined up about the simulation, the attack simulation monitoring techniques and how it relates to the OWASP top 10. And with any further ado, Robert, he doesn't need any introduction from me. I'll let him just take over and run the talk. Thanks everyone for joining us.
Thank you, Edmund. Let me share my screen here. I don't know why that didn't work, but there we go. Okay, so this is the presentation called "It's a NaN issue." A little play on words. This is about NaN. My name in particular is Robert Hansen. I am the CTO of Bit Discovery. Been CEO of a couple companies and written some books and stuff, but this really isn't about me. My co-presenter who couldn't be here today actually did some of the background research on how prevalent this issue is. And this is Zach Jones, a really, really great guy, works for NTT Security, application security, which was Whitehat Security, if you're familiar with them. So just a brief background because it's semi-relevant. So when I first started getting interested in Python, it was because I had written everything in Perl, and Perl is a very powerful language, very good at a lot of things, but didn't have certain libraries that I needed to do certain computations. And so I was either going to have to switch to Ruby or Python because of the two, and there was C I could also have picked for doing this very particular type of computation. And so people around me are like, you should do Python. It's great, and it's type safe, and a bunch of other things that they were kind of selling me on. So I knew nothing about Python. So I'm like, okay. And if you search the internet, people say it's type safe, and there's all kinds of reasons that's important. But from my perspective, I just thought it would be neat. I'll learn a type safe language. It'll be something I'd never tried before. One of the things about Bit Discovery that's very interesting is we basically have metadata on more or less every single server on the planet. So therefore, any weird thing that you might ever find anywhere on the planet could theoretically be something that you didn't expect it to be. And in practice, it almost always is. There's something somewhere out there with some weird character on it or some weird string that you would never expect or whatever. So, so that's sort of the background, how we got into this thing. So if you take a function, and I'm sorry if you're not a programmer or don't know much about programming, but I'll try to walk you through it. This would be like a typical function you might find, like check for numbers. So you get a string in to a function, and then you say, okay, test to see if it's a number or not. If you can convert it to a float, well, then it's probably a number. If you can't do that, then, you know, return a 0, basically. So this is a very common type of thing to see in programming languages. This happens all the time. The problem is in Python, you have this whole concept of NaN. And so I can inject, and I'll get to what that is in a second. I can inject a number or a float, a string, and another number, integer, and pass it through there and have this function that says, all right, check to see if it's a float. If it's not a float, return a 0, and basically run until you find something that isn't a number. So it gets 1.5 up here. That works great. And it gets this string, and you'd think, okay, this is not a number, but it actually can get cast to a float and it'll pass. It will crash on Bob, which it should, but you'd think it would have crashed on the NaN, right? That kind of seems like that would work. Well, NaN is a very weird little thing. NaN stands for not a number. It's a mathematical sort of placeholder when, for whatever reason, you can't perform that particular operation. So you can see, you can use uppercase, lowercase, print float NaN, print float capital NaN, lowercase, or some uppercase, whatever. It always just is NaN. But you have to be a little careful. There's sometimes when it's uppercase, prints uppercase NaN or whatever. So you do kind of have to pay a little attention to case, which is kind of annoying. You wish they just pick one and just go with it, but nope. It has a length when turned into a string of 3. It's not none, which is important. And it's also not the bread NaN. That's something different. It kind of acts like a number, sort of. So if you do numeric computations on it, it will act as if this thing's a number. It can be cast into a float, a Boolean, a complex. If you try to cast it to an integer, hexadecimal, octal, binary, or ordinal, it'll crash. So you have to keep it in one of these 3. It is most commonly a float, though, in case you're curious. It can, in the concept of bool, it is true. It is also, a null byte in a weird way. It also equals 1, which is interesting. And it eats variables. It has this weird consumptive thing where if you do something and you do a mathematical function with it, it'll turn into NaN. It rounds to the nearest NaN. It doesn't equal NaN, which is one of the weirdest things about NaN. So you can say, is NaN not equal to NaN? That is true. So it is true that it is not a NaN, but it is not NaN. But anyway, you can say A is float NaN. You can say, is A equals A, and that'll be false. So this is one of my favorite tweets on this topic. This is your annual reminder that NaN stands for not a NaN. And this is what he's referring to, this mathematical function where NaN does not equal itself. So there's these things that we're calling equivalence or failure modes. And this one's the incorrect equivalence failure mode. That is sort of, think of it as like bad design that you might see in reality out there, depending on what kind of code is out there. So let's say you have two messages, old message and new message, and they are identical. So this is someone hitting the button twice kind of thing. Typically, you'd like an anti-spam filter, anti-denial of service filter, something that does rate limiting to prevent the same thing from coming in over and over again. Voting systems are like this a lot. And if you see the same thing twice, ignore it. But if the message ID in this case is float NaN, and you say, okay, does the old message equal the new message, the message ID, does it equal itself? No, because NaN doesn't equal itself. So in that case, you can sort of bypass certain types of restrictions if you're asking, is it the same as itself? So there's this thing called the IEEE 754, which has this one sentence, all comparisons where one of the elements is a NaN should return false. Now that, if that was true, if that was always the case, at least you'd be able to say, all right, I can build a box around NaN. And if I ever see this happen, I'll know that it's NaN and this is how it's functioning, and you can sort of program around it. So I wish I could move this thing at the top. It's kind of in the way. So anyway, you can say math NaN is math NaN. That is true. Well, that's a comparison operation and it's evaluating to true. So right there, this non-comparison theory that the IEEE standard asks you to do is already broken. You get this, these are all working versions. So is float NaN false? Is float NaN true, false? Is it false, false? So this follows the IEEE standard. But if you say float NaN is not true, which is a comparison operation, it's true. Is it not false? It's also true. So it's sort of like it's taking this thing and deciding whether this is true or not, and then evaluating it based on that, instead of saying this whole thing will evaluate to false. So there's other versions of this. If float NaN, which is basically saying, is it true? Then print true. If is it not true, then it should say it's not true. It is both true and not true at the same time. So this allows you as an attacker to sort of like, depending on where you are in the code and depending on what the logic looks like, you can sort of program around it by injecting NaNs in a very particular way and kind of end up in weird places in the code that you shouldn't be able to get to. So this is another example of this. This is the incorrect equivalence failure mode V2. Where if you have a bid, let's say you're having some bidding system where, and typically you want to have the just higher than the highest bid to get in, but that's only because there's some limits around what you can put in there. If for some reason you're able to bid much, much lower than there, then of course you get the auction item way, way cheaper. So if you say the highest bid is float 999, so $1,000 basically, and you've bid instead of $1,000 or more, you bid float NaN. It'll ask, is your bid less than the highest bid? Because if it is, it should say less than or equal to, then you basically, you don't get the highest bid, and you're not the sort of marker for who is at the top. But because it's NaN, and NaN is both larger and smaller at the same time as some other integer or float, you'll end up over here and you'll have the highest bid. So you can inject NaN into sort of auction systems or whatever and end up being below everybody else or higher depending on what's happening, which we'll get to in a bit. So this is more of this non-comparison stuff. So you can have bool NaN is bool NaN. So bool, this sort of does make sense because bool converts things to the numeric 1. I think someone's trying to get in, by the way. I just learned. So this actually does make sense, and I think logically that's fine. If you say bool NaN equals 1, yeah, that's correct. But this gets a little weird. So bool NaN plus 1, it think like I sent in a string that's being cast to a float, which is turning into a Boolean, which should be a 1 or 0. It should be true or false, but it's getting converted to a 1, and then you're adding 1 to it, and it's saying, yeah, that's equal to 2. So this is absolutely not strict typing. This is what's called duck typing. And duck typing is if you take a variable and you say, what do you think it is? Well, if it looks like a duck and it quacks like a duck, it's probably a duck. Walks like a duck and talks like a duck, it's probably a duck. So that's duck typing. And this is sort of the definition of it. So everybody who's saying that Python is strict typing is lying to you. It absolutely is not. So part of the problem appears to be that there's this variable type inheritance. It isn't the whole problem, but this is part of the problem. So if you have true plus 1, it equals true, which we saw on the previous page. True plus 2 divided by true is now a float. True plus 1j is now a complex. And you can see it if you do run a type across these: bool, integer, float, complex. So you can end up in weird situations where I never started with any of these things, but because they're near in proximity to something else that kind of looks like some other variable type, you can kind of coax it into that other type. And so this one's bad because you can say true plus float NaN, and suddenly this Boolean becomes a float of the value NaN. So that's consumptive variable thing we're talking about. Duck typing is not type safety. It's a very different thing. So before I get any further, people are going to talk. They're definitely going to say, hey, there's this whole is NaN function. Are you going to talk about this thing? Because if you don't, you're just missing a huge chunk of how this is supposed to be defended against. So I looked at them. NumPy is NaN, CMath is NaN, and math is NaN. So NumPy is NaN, CMath is NaN, both sort of work. They work as you'd expect most of the time. So you can say float is NaN is true, bool works. Bool does not work rather, because Boolean again turns it into a 1. It kind of converts it, as opposed to continuing to be NaN. CMath also has the same problem. Complex, they both work, but in math is NaN, in complex it just breaks. So I wouldn't use the math is NaN. If you're going to use one of the two, use NumPy is math, NumPy is NaN, or CMath is NaN. Part of the problem, though, is this is making the assumption that you're checking at the very point at which you need to use it. And it also makes the assumption that it's not going to later on become NaN, at which point you need to check it again. So this is one of those things that kind of needs to be done all of the time, not just in one place. All of the code you're ever going to see, like examples of this, is all going to describe it as like, oh, just use it and it'll work. But it really is more complex than that. I'll get to it in a bit. So here's another example of this. So let's say you have some function that applies, let's say it's a web app that applies certain variable restrictions or certain access restrictions based on your user type. So for the user 0, you get no restrictions because you're the sysadmin. For the user, any of the other user types, you get some. So if I can coax my UID into 0, it says, well, first of all, make sure it's not NaN. So this looks like it works. I mean, it seems like this is going to work, but math.nan is not the same thing as math is NaN. Those things work differently. And so this will actually pass despite the fact that it really looks like it's going to work. UID is not 0. It's true. It's not 0. It's NaN. So down here, it's going to say, okay, for everything above this thing, apply some restrictions. So is it the number 1? Then it only has write restrictions, right? If it's 2, it has write and read. If it's 3, it has write and read and execute or whatever. But it doesn't have any of those because it's not above 0. It's not any number. It's NaN. So you can get in these weird logic issues where it feels really like it should be blocked, and you've tried your best to block it, but you can still end up on the other side of all this stuff and effectively get no permissions restricted based on your user ID. So these are things that do work, and I'm not going to spend much time on them because it doesn't really matter, but they kind of look like they shouldn't. String float NaN equals string float NaN. It's true because they're both being converted to strings, and strings can have comparison operations. Same thing with this, despite the fact that one's uppercase and lowercase, because the float NaN will convert this in lowercase ahead of time. All these things convert to true or false depending on what they are, but this is correct. They look weird, but they're right. but this is not so great. So if I take a summation of 15 and float NaN, it really should just break, because why on earth would you have the IEEE standard say that you have to have everything equivalence to false when you're doing comparison operations, but it's cool to do math on it? That seems very dangerous to me, because especially with no error messages, there's nothing to warn a user this is happening. So this becomes this very greedy little duck that comes and just consumes all the things around it. And it gets worse and worse and worse as this goes on. So let's say you have two books, right? Book 1 and book 2. And you're saying, I want to have a rating system based on it. So the user A votes 4.5, B has 5, hacker votes float NaN. And for book 2, you have float 2 and float 3. So clearly book 1, if you ignore the hacker there, it has higher votes. It's 4.75 on average compared to 2.5. But because of this float NaN in there, once you start doing this addition function, this little plus here, it doesn't look like it's dangerous, but it is. As soon as it touches this float NaN, everything else that it adds to it will become float NaN. And then when you do a lambda sort on it, it'll appear like book 2 has a lower sorted book order than book 2. So book 2 will win despite the fact that it has much higher ratings. So you can find this type of issue all over the place within Python's addition and subtraction, absolute, div mod, power, round, all of them convert into NaN or something like NaN. Division, multiplication, powers, all kinds of stuff convert to NaN. You can even do weird things like format it, and it'll actually come out like this as strings with percents and stuff in there, which is really bizarre. But yep, it's just this consumes it all. It doesn't care. So this is another one of those where, okay, I'm not allowed to submit a negative number, and I could reinforce it and say not larger than 5. It all does the same thing. It all gets passed. NaN will pass all of it. So you have a feature 1 and a feature 2. Think of this as like a voting system for different features that you want to have go live. Feature 1 has extremely high votes. Feature 2 has extremely low votes. But the person votes NaN on feature 1. And again, this consumptive behavior, it'll try to sum them all together with this summation down here. I'll say, is the sum of votes of feature 1 and feature 2, which one's larger? And feature 2 will win. So powers are a weird one too. So you can have 2 to the power 3, which is correct. By the way, it's really funny. If you do 2 to the power 3 to the power of 3, that'll work. If you do 2 to the power 3 to the power of 3 to the power of 2, that'll work. But if you do 2 to the power 3 to the power 3 to the power 3, your system will just sit there and hang and just process it forever, which is really interesting. Unless it's on like a really crappy box, in which case it'll just get killed because you won't have enough memory. But anyway, 2 to the power of float NaN is NaN. So this is actually correct. This is actually how it should work. 0 to the power of float NaN is also correct. That should also be NaN, because anything to the float NaN should just be NaN. But 1 to the power of float NaN is 1. So this is definitely not correct. It should be NaN. And the reason I think this happens is somebody somewhere in the code said, if you ever see 1 as the first number, just assume, because 1 to the power of whatever is just 1, despite the fact that it's NaN. So it's just ignoring this NaN. So if you ever do numeric computations with powers and you end up with NaN, you're going to get bad answers, which is not good. And you really shouldn't trust floats at all. If you do go through and read some of my tweets, my most recent tweets, you'll see how broken floats are in Python. But anyway, but so this one seemed down here seemed incorrect to me. But it actually turns out that this is correct. This actually is the way this is supposed to work with these parentheses. This I thought was going to be NaN, but it is not. It is just deciding that it's going to be -1 because everything inside here, 1 to the power of anything is just 1. So it's -1. It seems like this is going to be NaN, and it really should be NaN, and it's very broken. This one, on the other hand, seems like it should be NaN, but actually is correct. Bizarre. Because it is NaN. So sorting functions are an absolute disaster in Python. So let's say you have 8 is the highest on the list, 2 is the lowest or halfway down the list, -5 is the lowest in float NaN. So it'll sort it as what you'd expect, I guess, sort of -5 to 8, and NaN is over here. So NaN is infinity or greater than infinity. I think that's kind of what it's showing you. So if you do the same thing and you do a max sort with math infinity and float NaN, NaN will be the bigger of the two. NaN is the larger of the two objects. If you sort 8 to math infinity and float NaN, this confirms it. 2, 8, infinity, and then NaN is the largest of the four, which it seems a little bizarre. It seems like there shouldn't be anything larger than infinity. So if you do the minimum though, and you say float NaN and negative math infinity, NaN is smaller than negative infinity. So math, if you sort it out and actually show the values, it's NaN and the negative infinity. So NaN is both bigger than positive infinity and smaller than negative infinity. And so then if you put -8, 5, float NaN, -11, math infinity, -22, a lot of different stuff, NaN will appear to be smaller than negative infinity. So, or than positive infinity right here. So up here, NaN was larger, down here, NaN is smaller. And this one is really totally broken. So 1, 6, float NaN, 14, 2, 1, 6, NaN, and then 2, which should be over here somewhere, and then 14. So NaN has this weird thing that it does where it kind of breaks sort. It like puts the wrong things on the wrong sides of sort, which it can have all kinds of, and this is repeatable. You can do this over and over and over, and you always get the same result. So this is a really interesting payload if you're trying to break sort in some interesting ways. So for instance, let's say I'm bidding on something, 4, 6, float NaN, and 2. This is the second to last bid, and I use a trash account for that. And this is the last bid, and the hacker actually makes this bid. So the bid is 2, which is the lowest bid, but before that is float NaN. If you sort that out, it'll basically just say this is the only bid. It is the top bid. It's the bid you're after.
If this team, the folks on the call today, rank by easiest to demo and POC and sell, what would it look like?
Are you talking about how to create payloads? Hello? I think maybe somebody's...
Nick, weren't you involved in that enormous like 730K backup deal last year? Or
I think we're talking about different things, different. So I think someone's not muted.
Yeah.
So you can basically win the bid by virtue of sort being so broken that it'll pick the one that's off the top instead of picking the highest bid. And so Python will say that this is not a bug in sort, despite the fact that everyone expects sort to do what's in its name, to sort. And so there is a bug out there that Marco Sola put out there where he basically said the same thing. He said that the float NaN breaks sort. And Steven DePrano basically said, effectively, Marco, I'm done with this thread, write a pep or move on. He was totally dismissive. And then much later on, about a year or so later, he said, having sort check every item to see whether it's NaN or not would be unnecessarily slow sorting down too much, which is true. It would slow things down a lot, but that doesn't mean that this isn't an issue. It just means that it's slower to fix the issue. It's a very big performance impact if you actually want to do this correctly, which means that it's probably never going to get fixed because of this huge performance impact. Dictionaries are another mess. Dictionaries are supposed to be singular key value pairs where there's one key, potentially lots of sub values under the value, but one key. It's just like a dictionary. In fact, the way Python describes it, it's best to think of a dictionary as a set of key value pairs where the requirement the keys are unique. And this is very important. So if I have two keys where the one key is float NaN and another key is float NaN, that should compress them down. One of the cool things about dictionaries is they have a compressive function where it basically just takes two variables that are the same, and it'll take the second one and overwrite the first one if there's a new one. And you basically only end up with one key, which is great. It's kind of a deduplication feature. But with float NaN, you'll end up with two keys that are the same. Both are NaN. Same thing with complex, has the same thing. So you can end up with two keys of the same name, which shouldn't really be possible the way they describe it. So you can here's an example of that. So let's say you have a voting system where the user ID is NaN, and you just keep injecting it over and over again, well, technically that user should only be able to vote once, and this should all get deduped. So you're voting for hacker 3 times, okay, but it's all the same user ID. Well, it's not. In Python, these actually end up being 3 different user IDs, despite the fact that they're all identical. So Sue loses, hacker wins, despite the fact that only one person voted for hacker. So even though they try to dedupe the function. So what's going on under the hood there is it's using this thing, an ID. So if you have 2 math NaNs and you ask, okay, show me all the IDs, there'll only be 1 ID. So that has that deduplication thing I'm talking about. And if you actually dump the dictionary, you have just 1 thing in this dictionary. So math NaN works the way you'd kind of expect it to. Same thing with numpy NaN. But when you define it yourself, or sorry, this actually works for some reason, float NaN, and you can do the same thing there. But if you have 2 different float NaNs where you actually define them yourself, you end up with 2 different IDs, which is why that's occurring, which is not great. Now, I thought that would be the end of that story and there'd be nothing weirder about it because that's already pretty weird, but you can end up with different types of complex RNaN. I grab the imaginary number out of it and float and throw all kinds of stuff in there, and they'll actually be identical. Despite the fact that these things look completely different and I'm defining them differently. And on this previous demo, they will be different inside of a hash. And sometimes they're the same. So I don't know why that's the case. I don't know if that happens all the time. I don't know if that's a performance thing that occasionally this occurs. I don't know if it creates pointers, and if those pointers exist. Sometimes they're there, sometimes they're not there. So there's a lot going under the hood with Python that you probably want to dig into if you really care about that. So so NumPy is sort of the implementation of number Python, like how to do all sort of number processing, sort of higher level number processing. So I did this on a Mac. I think this one is a Mac. Yes. Did this one on a Darwin box. Yeah, Mac. So I basically said, all right, take a NumPy and NP NaN, which is NaN, and give me the integer value of the 0th array, which is this NP. And instead of giving me NaN, which it should, because that is the thing, or breaking, because there is no such thing as an integer version of NaN, it returns 0. Which definitely is a number. So it went from something that wasn't a number to something that is a number. It actually changed it, not just from a variable type perspective, but it actually created value where there was nothing before. And there's another version of that. So you can say, all right, well, I'm going to request float NaN. Okay, well, that's fine. Well, if the request is not 0, because it can't be 0, then assign the UID of whatever it is. You're allowed to be whatever ID you want, just not 0. Well, once you convert this to an integer and you apply it the 0th array of that integer, it is 0. It became 0, despite the fact that it never started off as 0. It started off as NaN. So you can end up as UID 0, but it gets much, much worse. So on Ubuntu and FreeBSD, same code. You have NumPy as NP. You have the same code, this identical code, and it just says dump this integer. Instead of it being 0, it's -9 quintillion, which is the largest negative value of a 2-sided int 64, which is -2 to the power of 63. So I suspected that this was a 64-bit problem. So you can actually define it in Python. You can say int32, and then it was just this other large number, negative number. Int16 was 0, int8 is 0. So I think that's somewhat related to the problem, but you cannot rely on NumPy to handle NaN properly as a result of that. But this -9 quintillion thing is a real problem. We'll come back to that in a second. So I think what's going on here, this is great that this guy, C. Harris, put out. Many people use NaN as a marker of invalid data. That may not have been the original intent when it was introduced, but that is what the evolution has made of it. And I think that's correct. I think that is what's gone on here. This guy had a really good analysis of it as well. He's like, if I had to do it over again, Python's float comparison functions would impose a total order, and Python would have grown a math IEEE compare X versus Y with whatever flags you wanted function for the small segment of people who actually want unordered outcomes. Because you think sort is going to sort. Well, if you're expecting that it doesn't sort for some reason and you're cool with that for some performance reason, then you should have an unordered sort function, not a sort function that everyone relies on for sorting. So that is very broken. And then if you're actually interested in trying to implement a better version of sort yourself, there's this guy down here who did it. You really have to be very, very careful with this though. As I'll show you later in the presentation, it's not foolproof, and it allows you to have NaNs as both bigger than positive infinity and smaller than negative infinity, which may not be what you expect. I just expect NaN to explode or give me warnings. Like whenever I see NaN, I probably don't want to be operating on NaNs. So you can end up in situations like this where I have a string called NaN and I convert it into a float, and it says, okay, well, I'm not allowed to have any negative numbers, but then I'm going to convert this thing into an integer and run some transfer on it. So this would be like a bank system where if you transmit a positive variable to a bank, you're submitting money to them. If you submit a negative number, it pulls money back. Well, if I submit a NaN into the system and convert that into an int if it's a Unix box or Linux box or FreeBSD box, it'll, instead of sending as NaN or sending nothing, in the case of Mac, it'll send negative 9 quintillion back, which is more money than's ever been printed. So NaNs can be all kinds of crazy syntax, new lines, carriage returns. You can put pluses and minuses and J's, and all kinds of stuff. There's all kinds of weird things can get injected. You can end up with NaN. Here's a list here. But this is probably the most likely type of injection. You're going to see somebody taking a piece of JSON. So this will typically be an API endpoint where the variable name is whatever, call it shoe size or something. And NaN has to be a string, and it has to be uppercase NaN, lowercase a. It has to be exactly this format. You can't do this crazy stuff I'm doing up here. It will break, but this will allow you to inject something where you might expect maybe the pager number to be an integer, and suddenly you get a float, despite the fact I never said the word float anywhere in here. So this is sort of a bonus round. It doesn't seem like it's related, but it is incredibly very useful. So let's say I have a car speed and I'm able to inject a negative infinity. And I say, I'm going to accelerate at 5 meters per second or something. And I say, okay, but not past the speed limit, which is 60. So I say, okay, while one, if the car speed is less than the speed limit, so the car speed is negative infinity, then take the car speed and add an acceleration rate of 5, and then tell me what the current speed is, and then just keep looping through that forever until I reach the speed limit, and then jump out of it. So the problem is anything plus negative infinity is still negative infinity. So if you have a current speed of negative infinity, you add 5, you have negative infinity, which is not greater than 60. It's less than 60. So this will basically just get you in a tight loop where it's speeding you up forever, and you won't be able to get out of it. So it'll basically send you into warp, or you could have the exact same thing with, and apparently there was this bug, there was an airplane that you should never have a negative number. Like an integer should always be a plus. It should never be a negative in the case of altitude, because there's no such thing as a negative altitude. But there is such a thing as negative altitude. Somebody went in below sea level at some desert or something, and suddenly all of a sudden it's like, okay, well, I have to get to a positive number, I have to add however far I am from, I'm in space right now, I'm incredibly high as a negative integer, converted me to a very huge positive integer. Like I need to decline my altitude extremely fast, and then it just nosedived into the desert. So this is a very similar type of issue. You could have the same kind of thing with nuclear meltdown or whatever. You just kind of keep adding numbers because you never get to that maximum number. So you can have situations like this. So this is why I'm curious about infinity, because it allows me to get to NaN. So if you take infinity and you divide by negative infinity, you get NaN, or the mean of infinity and negative infinity is NaN. So let's say you had a web app. This is where it gets into OWASP stuff. And you have variable A is infinity and variable B is negative infinity. It's supposed to do some function on that. You can say, okay, is variable A NaN or is variable B NaN? Nope. Well, all right, it's totally safe to perform some mathematical function on it, and now you have NaN. So you can run is NaN all you want up here, but it doesn't matter because I can get to NaN later in the code. So all the current guidance on how to handle NaN is only kind of half looking at the problem. Similarly, you can get there. Remember that JSON I had before was just NaN. Well, you can do the same thing with infinity. You can inject IE plus, well, you don't have to have the plus there, but IE some huge number. I think it's over 330 or so, it'll convert it into infinity. And you can do the same thing with things like this, negative 47,013e. This turns it into exponent, and then you get negative infinity. Same thing. So this is the fastest path I've ever seen to get to NaN just using mathematical functions. So this seems like an idempotent variable. 0 times anything is supposed to be 0, but in this case, it's not. 0 times 1 to exponent 310 is NaN. So yeah, 310, not 320, whatever. This allows you to get to NaN just by saying 0 basically multiplied by infinity is NaN. So the same thing, infinity modulo infinity is NaN, or infinity, sorry, this is not infinity, this is less than infinity, plus another non-infinity number. So you can actually end up injecting 2 things where you ask the question, are either of these things infinity, or either of these things NaN, and you really are trying your best not to get in this rabbit hole. I can take 2 non-infinity numbers, add them together, and end up with infinity. Or I can end up with 2 non-infinity numbers and 2 negative non-infinity numbers, and add these together, subtract these from each other, and now you end up with NaN. So, so you can take a large integer, so 10 to modulo 360. So this is a very, very large integer, and then you can multiply it times 1, but a float 1, and it'll crash. It'll throw an overflow error. So there is some error handling in Python. Someone somewhere went, maybe we should have some checks on this, but only, this is the only place I saw it. The other version of this, the thing I saw was 0 to the power of 10 to the modulo 360, which should just be 0. It throws the result is too large error. This is also very weird, a way to get to 0 where you normally wouldn't allow 0, which is useful when you want to multiply 0 times infinity. You can have 0.1 modulo 330 and you have 0, or negative modulo some very large number, and it is negative 0.0, which blew my mind that such a thing existed. But it's basically, think of it, instead of the largest version of infinity, it's the smallest version of infinity. The largest version of infinity goes on forever. The smallest version of infinity is like, take something, divide it in half, take that thing, divide it in half, take that thing and divide it in half, and keep doing that forever. And as you approach 0, depending on which side you're approaching on it, is the positive or negative 0, which is bizarre, but it works. So you can have 2 to the very large power. So this is the positive version of infinity times 0.2, some large number, which is the smallest version of infinity. So large version of infinity times small version of infinity is NaN, which is bizarre, but it is true. Okay. So if you take some large float that is a hexadecimal, let's say, and you multiply it times 20, for instance, this will work. As long as you can coerce it into a float, it works. So it works with hexadecimal, binary, octal. Remember all those things I said you couldn't use before? Well, as long as you can get them back into float somehow, you can still get to infinity, and therefore you can get into NaN. This is actually my favorite one because it's so ridiculous. So 1 very large number dot minus 1 very large number dot, it's the same number, by the way. This should just be 0.0. It should be a float of 0, but it ends up being NaN, which is bizarre and broken. So the most important thing I can say about this deck is do not actually use NaN or infinity or negative infinity or anything that can get you to those things in production, because there is a lot of really dangerous denial of service type attacks that can be performed without really realizing it. So you can inject it in one place. Let's say you inject it in like some normal piece of code that just gets logged somewhere in some database. Then later on that night or a month later or something, someone runs a batch job and collapses all that data down and does something with it. All of a sudden, this thing you thought was very, normal and fine, it turns into something really damaging where it's collapsing data, destroying data, doing unknown, bizarre things like adding things forever kind of thing, without you really realizing the floodgates could start opening up or whatever. There are some examples of where this kind of thing has happened before. For instance, one guy was saying he took this very, very large array of different variables, and he had NaN somewhere in the middle of it. And he took the lowest 10,000 results And he thought he was operating on them, assuming that that was correct. But it actually turned out that a huge chunk of the smallest results were on the other side of that NaN. And so he was getting very weird, bad data by virtue of one errant NaN somewhere in the data. So you have to be very careful how you do this. There are some indicators of Python on the internet that you can use to find this, G-Unicorn, et cetera, Twisted. There's some behavioral level stuff that Zach was able to find that kind of tells you from an error condition that this thing must be Python. There's predictable resource locations in certain frameworks. Anytime you're looking for this kind of thing, generally you want float-like strings. If you can find float-like strings, everything starts off as a string in the web, everything. But eventually it gets coaxed into something else, or it stays a string. You're looking for the ones that turn into floats or float-like. So they might be an integer, but you might be able to coax them into. So so instead of injecting 1, you might inject 1.0. And if it still works, well, then it's accepting that float. Or it might be casting it to an integer. So you might need to do further testing to see what happens. Integer-like strings are also good because generally speaking, people don't realize that they can get cast to floats. And then if you can get stuff like JSON to inject, where someone's expecting an integer and so therefore they never cast it to anything, they're just always expecting it to be an integer, those are sort of the most ideal locations for injection. If you can inject math functions of any kind whatsoever, you can get yourself to infinity or NaN very easily. If you see things converting things into decimals or to integers in weird places, not necessarily where you inject, but other places, there might be places along the way that are float and float-like applications. Lots of different versions of the same thing you can inject to sort of detect whether this is collapsing it down into a float or not. All this basically saves you time when you're trying to inject, because you don't want to just arbitrarily inject. First of all, you don't want to inject ever if it's production. So I've said it before, I'll definitely say it again. But if you're doing it in like a pre-prod environment or a black box environment that's not prod, and you have to be very careful that this data doesn't end up in prod eventually or using the same database as prod. Just because the front end is not prod doesn't mean that the back end isn't, from a logging perspective or a SIM perspective or something else you might have built. So the Whitehat guys or NTT guys ran some analysis for me over just over a month period, a population of just under 10,000 sites. They found about 2% of them have some int-like parameter that looks like it might be injectable. 0.53 that have some JSON-like, which isn't super surprising because that's not that common a thing to have. Despite the fact that JSON is very popular, it's still not something that gets injected onto every website. Python server headers, 0.16, so that's very small population. But Python with error messages that indicate that it is Python is 6%. So we think these numbers are all low, every one of them. It's just very difficult to exercise all of the breadth and scope of the complexity of any app. Plus, keep in mind something that you think is definitely not Python and may not be Python, might be whatever, Ruby in the front end or something. It might eventually lead to Python on the back end that does some backend behavior or API call to some third-party service or whatever. So these are some of the payloads. This is sort of the TLDR if you kind of missed the beginning. A lot of different ways to inject NaN or infinities, positive infinities, ways to get to infinity, et cetera. So very easy to work around anybody's like is NaN type controls that they might have in place. So kind of in conclusion, Python is definitely not type safe. So again, if you ever hear anyone say that, please just tell them they're an idiot. It's duck typed and it's also not IEEE 754 compliant. It is actually very easy to fix if you're a competent dev. You just need to make sure you never ever get to the point where you're getting to infinity. You need to make sure you always making sure it is NaN before you do every calculation. So it is very bad from a performance perspective to fix it, but it is, very easy to do technically. There's no reason you have to do anything fast to mitigate this. The most likely place you're going to see this is just in value error crashes. It's trying to convert it to an integer and you're going to get a value error crash. So the vast majority of places you're going to inject, nothing's going to happen. So the very bad news is you can't test this in production. You really, really can't. I can't stress this enough. is easily one of the most dangerous things I've ever come up with in terms of just blind injection. Like, it's almost worse than drop table, because at least drop table, you know it happened. You know that it happened or it didn't happen. With this, you could wait 6 months before the bad thing happens. There's really is no way to know. It affects sorted, min, max, numpy, int type functions, format, sum, round, absolute, div mod, all of the math functions, and on and on. Basically, every single thing I tested had some weird variant of this if it does any sort of mathematical operation. As of version 2.9, I checked the snort rules and there is no concept of NaN anywhere in them, which means no one is looking for this. It's not something that is ever going to be trapped anywhere by anybody. So go ahead and inject NaN all day long as far as snort rules are concerned. There was 2 presentations about NaN that I was able to find. One was at NotCon, Secret Life of NaN, great presentation. But that was about JavaScript version of NaN injection, not even a NaN injection per se, but about how NaN can cause all kinds of problems. JavaScript as a front end thing for your browser is generally not quite as dangerous, or it's usually just dangerous for one person. It's not like going to take down a website or whatever. So while interesting, perhaps not as dangerous. The other one I found was in Java, and this is on No Cheat Plus. It was an issue where somebody was able to inject either a NaN or an Infinity, and they're not sure which, that seemed to allow people to, in Minecraft, jump across the map extremely rapidly. Now, this bug's been open since 2016, so it's closed in the sense that no one's even looking at it at all anymore. So probably whatever happened was fixed, but no one really knows necessarily what was fixed exactly. So, and we're not clear even what the bug was, but it seems like it was probably this NaN injection thing, and that was people's speculation. In case anyone wants to know, I did submit this as a CVE to MITRE. MITRE kicked it back and sent me to Red Hat, who apparently is in charge of Python's bugs, for instance, for some reason. So they responded, hello again, after further analysis, this is now considered not an issue. Quote, Python is a fully featured programming language that allows you to write all kinds of programs, including insecure ones. The reject request was sent to MITRE. So I think this is a bizarre answer because it is absolutely an issue. It's just not an issue in the same way like a buffer overflow is, despite the fact that there is an integer underflow within this presentation. So I really don't know what they're talking about, but that's great news if you're an exploit developer, because you can go all day and no one even can see this coming. It's completely unknown to anyone who's relying on any sort of CVEs to protect themselves. This might make sense as a CWE, and I'm kind of investigating that to see if I can put it in there, because otherwise, really, no one will have any idea that this is going to happen. So that's the majority of the presentation. I'm certainly open to answering any questions you have. There is a GitHub repo with some code samples and a slightly earlier version of this deck. I'll see if I can get Zach to update this, but anyway, all the majority of the stuff that you care about is going to be in there, and you feel free to test it. It is designed to be as easily tested as you possibly can. So if you have any questions, you can reach out to Zach or I can answer them right now.
Thank you, Robert. If anyone has a question, please type it in the chat box, or you can unmute yourself and ask the question live.
Unless it's, would you please repeat what you just said? I wasn't listening.
Well, you beat your own record. It's less than
I know, I did it fast. I think it's because I skipped over a little bit of Zach stuff to save time.
I do have a question, actually. I'm curious if you've, if you can speak to any issues you've found maybe in bug bounty programs or that kind of thing. And, how do companies normally receive these type of problems? Do they immediately kind of discount it because it doesn't seem like an overt issue? I guess connecting it to some kind of larger impact seems difficult, especially the case you mentioned where there's some kind of cron running that eventually breaks, that kind of thing. But yeah, I'm just curious
Well, I would never, ever test this in a bug bounty because it's too dangerous, way too dangerous. Unless you really knew it was a fully isolated system where there was no back end way to get to prod from there. But unfortunately, like I am aware of at least 20 different examples in my pen testing career where people are like, it's fully isolated, it's cool. And then all of a sudden I'm getting these emergency phone calls like, what are you doing? Like all our customers are getting spammed like crazy. I'm like, well, I didn't hook it up to your production mail server. You did that. And so
it seems like it could be devastating, in
yeah.
so many different ways that, maybe you as a researcher don't even realize too. You just kind of send it to an API and that's it.
Yep, that's right. And I said it before, but maybe it wasn't super clear. So let's say you send some request in, does something in the back end. That thing may not even be Python. That you could be completely safe from that perspective. Like the dev's like, I don't write Python, so it's cool to use NaN injection to prove that we're not vulnerable to it. Later on, they send a request to some third-party API that is running Python, and all of a sudden, all hell breaks loose, and all kinds of things can happen. Yeah. So it really is very unsafe. Like I would never ever test this in a bug bounty.
Awesome, thank you.
Yeah.
Hey, Robert.
Yes.
I mean, with such a crazy of an issue there, is there another? I know, like when I write JavaScript, I work with web development stuff, basic front end stuff. I'm not using NaN. I might, check and see if it's 0 or even use null and stuff like that. Is there another way to, and I'm just starting to learn Python cybersecurity, not using NaN at all. Is that also a possibility to use something else instead of just using NaN?
Well, I mean, you could use anything you want, but then, so I think NumPy originally started using NaN because they didn't really understand what it was. They didn't understand, which is bizarre. I really think this is bizarre, but I think it's true. I don't think they really got the complexity of NaN and the variable consumptive nature, especially in Python, and especially how it would eventually be used. So I would probably try to stay away from NaN whenever possible, unless you knew it could never be NaN. And then anytime you see NaN, throw it on the floor. You know what I mean? Like treat it as a blank variable as opposed to a mathematical function, and make sure you delete it before you use it. So I think that's part of what that is of the integer thing within Python, within NumPy was supposed to do. It's like take NaN anytime you see it and convert it to 0. Which it really shouldn't do. It should just fully get rid of it or something, or at least throw a warning or something, right? Just break, but it doesn't do that because any other time I convert anything to an integer that it's NaN, and any other way it does break. So it seems very inconsistent and dangerous. So I don't know if that answers your question, but it's very dangerous.
Yeah, thank you.
We also have a question in the chat that says, is there a preferred language or online stuff?
Preferred? I don't know. I don't know if I can answer that question. It kind of depends on what dimension you mean by preferred. A lot of people have a lot of luck with Java, but Java has its own issues. I won't mention Log4j by name, but Log4j. So you really, I think all of them have their own pitfalls. I think what annoyed me most about this is Python's sort of attitude towards Marco, because it really, all they had to do was say, we're totally understand it. Next version of Python, like Python 4, for instance, we can create something called warnings. We can create an unordered sort for the people who want that. And so people who want to upgrade can just change the word sort to unordered sort for whatever reason they want unordered sort. It's like, might as well just give me whatever's in the string, because that's the same utility, but or same array. But they didn't do any of that. And they didn't offer any new guidance. They didn't warn anybody. They didn't do anything. They just said, you're sort of on your own. And as they said, it is not an issue, and you can write insecure code. I think that which is a bummer, because I was kind of hoping that they would do a little bit just to like, hey, why don't we create some better warning material, better guidance on NaN, like, please check out this presentation. If you don't really, if they don't even want to write anything, just point them to me or whatever, anything, but nothing. And so I have a feeling that all of the programming languages have little nits like this that you could pick on and find bad stuff in. I did not press on any other languages just because Python was sitting there and that was the one I was using when I was doing this research. But I suspect a lot of other languages have sort of similar problems. So I can't make any strong recommendations one way or another. Also, I'm a terrible programmer. A really, really, really bad programmer. So I shouldn't be touching any of this code. It's sort of Python's, the way it broke that kind of made me look at it when I normally would just write something quick in Python and Perl, which was how I used to do things, and call it a day. Python kind of makes you look at it in a way that I probably shouldn't have, because as soon as I started to, I've started unraveling all kinds of stuff.
I'm not a programmer, but what worried me most is the random nature of the outcomes based on the combination of things that you put on that those lines.
Yeah.
And also the fact that it's it doesn't have most of the time, it doesn't give you any errors.
Right. Correct. Yeah. The only time you're ever going to see an error in practice in real life is when you're injecting in an integer. You'll see a value error. But that just basically proves that it's Python. So now you've done some fingerprinting, and there might be another place somewhere else on the site that is vulnerable. So it's not as good as it sounds, I guess. It's like the one time it crashes, but it should really be crashing all over the place, or at minimum be following the IEEE standard and making it easy for a guy like me to write a standard library that just works uniformly across everything.
So besides,
there's another comment that says Python has type annotations now too. I wonder if enforcing it would at least reduce some of these issues.
Reduce, absolutely. Yeah, if you, especially the JSON version of that. So you get a string in and you start operating on it. You don't know what it is ahead of time. So if you use the type annotation and or you don't even need that. You just say convert it back into an int. I just want this to be an int. I thought it was an int. I just make it an int, and that will do the same thing. So yeah.
Any other questions for Robert? There's a question in the chat that says, how can we do unit tests, system tests with so many oddities?
I have no idea. I have no idea. I mean, I guess the simplest way is just start injecting NaN everywhere and infinity everywhere, and non-infinity but close to infinity numbers to see if you can get to infinity from there. And if I had to pick one more thing, try to inject math functions. Those four things I think will exercise pretty much anything you'd want to know about whether this is going to have an injection failure, at least on the presentation layer. It won't tell you anything about down the road and how logging functions handle it, or how security tools might read it and misbehave, or how APIs that might be called out later on will handle it. Like, there's so many gotchas. This ends up being spaghetti code within your own code, just trying to follow the path, the code path, and how variables are used. If you ever see any math functions, you're in trouble, because you could start off with something benign, and all of a sudden you have inf. And once you have inf with something benign, just like divide by 0 or something, which would normally just give you an error, suddenly turns into NaN. So it actually reduces errors in some weird ways, which doesn't seem like that would make sense, but it does.
Right.
Yeah.
We're almost at the top of the hour. And there's another question. Are there any static analysis tools for Python?
I don't know for a fact. I think NTT does have one. I think Veracode has one, but please don't quote me on that.
No. Okay. Well, this was really, really great. I really enjoyed it, and I'm sure everybody else did, and comments are reflecting that in the chat window.
Great.
Thanks again for attending and presenting, Robert. We really appreciate your time. Thank you, everyone else, for joining us during this call. The recording would be up on our YouTube page in a few days. And please, if you know any speakers that you like to hear, please send them our way. And have a wonderful rest of the week and enjoy your day. Thanks again.
Thank you,
Bye-bye,
everybody.
everyone.
Bye.
Thank you very much.